Welcome back, students. Today's our last day on thermodynamics, and I wanted to take this time to talk about some practical applications of thermodynamics and how understanding thermodynamics can be extremely useful for humans and for society in general. As a result of physicists investigating and learning all these details about thermodynamics and how heat works, amazing revolutionary inventions have been made, such as the refrigerator, the heat engine, and I'm going to link two videos in the description below to give a good explanation of how heat engines and refrigerators work. For this video, I'm going to focus on temperature conversions between the different scales, between Fahrenheit, Celsius, and Kelvin. And I also want to show you an equation that you can use to calculate how much heat is being transferred during a temperature change that is dependent on the substance that is exchanging heat. But first, I'm going to start off with temperature conversions, and we'll begin with how to convert from Fahrenheit to Celsius. Okay, if we were converting from Celsius to Fahrenheit, we could use this equation, which says that the temperature in Fahrenheit is equal to 9/5, or 9 divided by 5, times the temperature in Celsius plus 32. I'm going to do a quick example now. If I want to find the temperature of Fahrenheit at 40 degrees Celsius, okay, I need to plug 40 in right here, and then I just need to plug my numbers in a calculator. Alright, and this gives me 104 degrees Fahrenheit. There you go. Okay, next I'm going to find an equation that I can use to solve for temperature at Celsius if I'm given Fahrenheit. Alright, if I want to go the opposite direction, then I would need to have an equation that has temperature at Celsius by itself. So to do that, starting with this base equation that I had for Fahrenheit, I'm going to have to isolate that variable, so I need to get the 32 out of the way and then the 9/5 out of the way. I always start off with what's being added or subtracted. So here I have plus 32, and the opposite of that is to subtract, so I'm going to do that to both sides of the equation. Okay, now I have temperature in Fahrenheit minus 32 is equal to 9 over 5 Tc. Now I need to get rid of this 9 over 5. I see that the 5 is being divided, so the opposite of that is to multiply. And since I have multiple terms here, I have to multiply all of them by 5. This lets me cancel these 5s. And then the last step, I have to divide this 9 because it's being multiplied to the t. Now I have an equation that I can solve for temperature in Celsius whenever I'm given Fahrenheit. I have to subtract that by 32, and then multiply by 5, and then divide it by 9. Okay, so I'm going to clean this up real quick. Here's my Fahrenheit equation. Here's my Celsius equation. And now I'm going to talk about Kelvin and how we can convert from Celsius to Kelvin. Okay, if we have the temperature in Celsius, all we have to do to convert to Kelvin is just add 273. So this one's not too hard. And of course, if you're going the opposite direction from Kelvin to Celsius, we'd have to subtract 273 to both sides here, and we can get this equation. Okay, so we can use all these equations to convert between the different scales of temperature. Okay, the next thing I want to talk about is how to calculate how much heat is transferred whenever something changes temperature. Okay, I'll use the right side of the board for this. Alright, in this equation I have heat energy, which we use a Q to represent, is equal to mass times this little Cp is called specific heat. And what the specific heat is, this is something that depends on what substance is exchanging heat. Different substances exchange heat at different rates. This specific heat will tell me how much heat energy I need to add to 1 kilogram of some substance to raise the temperature by 1 degree Celsius or Kelvin. So some substances have very high specific heats like water, and some substances have low specific heats like some metals like copper and gold. It takes very little energy to raise the temperature of copper and gold, whereas it takes a lot of heat energy to raise the temperature of water, which is why it takes so long to boil water on the stove. And then this delta T right here is just the change in temperature. But the one thing I need to specify here is that it has to be in Celsius or Kelvin. Okay, so we can't use Fahrenheit in this equation. We have to use Celsius or Kelvin. So if you're given Fahrenheit, you're going to have to use these equations to convert to Celsius or Kelvin. I'm going to do an example now where I calculate how much heat energy is transferred in water. Okay, I'm going to go ahead and erase all these labels real quick. Okay, let's say I have a mass of 5 kilograms of water. Okay, I can look up this value for water, the specific heat for water is going to be 4,186, and the unit for specific heat is joules per kilogram degrees Celsius. Okay, and let's say that the temperature changed from 10 degrees Celsius to 100 degrees Celsius. Okay, if I know it went from 10 to 100, then the difference there is going to be 90, so my delta T is going to be 90 degrees. Okay, so now I have all of these variables. I can plug them into my equation to solve for how much heat energy is transferred whenever the temperature changes by that much. Okay, so I plugged in my mass, 5 kilograms, 4,186 for my specific heat, and then 90 degrees for delta T. Now I just have to multiply all these numbers. Alright, and I found that during that heat transfer, there was 1,833,700 joules of heat energy transferred. And this heat, of course, went into the water, which is why it raised its temperature. If my temperature change was negative, if it cooled down, in other words, then the heat energy would be negative, which just implies that it lost heat energy. Okay, so I have all of my equations here for temperature conversions on the left and my heat transfer equation on the right. I hope this video helps you understand how you can use these equations to do some practical work with thermodynamics. And I encourage you to check out the other videos on how a refrigerator works and how a heat engine works. Both those videos are extremely interesting, so please check them out. And thank you guys, I'll see you next time.